Okay, hi everyone. In this video, we will be looking at the 2012 A-Level H2 Math paper, question 10 on application of differentiation. So in this question, we are given a model of a concert hall made up of the hemisphere, the cylinder, as well as a base surface, which is a circular disc. Okay, so the three parts are joined together as seen in the diagram. In part 1, it is given that the volume is a fixed value K and the external surface area is a minimum. So we are supposed to use differentiation to find the values of R and H in terms of K. So first thing, volume. Volume of the cylinder is given as pi r square H, and then volume of the hemisphere 2/3 pi r cubed. And the question tells us that this volume equals to K. So let's make H the subject. K minus 2/3 pi r cubed over pi r squared. We do not like to have a fraction in a fraction. So what we can do is you can multiply 3 to the numerator and 3 to the denominator to get rid of the fraction in a fraction situation. Okay. So this is something that we will be using later. All right, H. The next thing that we know, or rather the next thing that we need to find, is the surface area. So surface area equals to pi r square. This pi r square is the area of the circular disc at the base, plus 2 pi r h. This is the curved surface area of the cylinder, plus 2 pi r square. This is the surface area of the hemisphere. All right. So we put them together. We have 3 pi r square plus 2 pi r h. But from the earlier working, we know that h is this. Okay, so you can replace h with this expression. Simplifying, 3 pi r squared plus k 2 3k minus 2 pi r cubed over 3r. So what I'm doing here is I'm cancelling this pi r with the denominator. All right. Then after that, we simplify it further. 3 pi r squared plus 2k over r minus 4/3 pi r squared. So we can put all the pi r squares together. We have 5 over 3 pi r squared plus 2k over r. Okay. Then after that, we want the external surface area to be a minimum. So we need to perform some differentiation. Now my dA dr will be 10 over 3 pi r minus 2 over k r squared. So I'm doing term by term differentiation. And because we are finding the stationary point, stationary value, you equate the first derivative to 0. And we try to solve the r from that. So 10 pi r equals to 2k over r squared. So if you do your cross multiplication, 10 pi r cubed equals to 6k. R cubed equals to 6k over 10 pi, which is equals to 3k over 5 pi. And then you cube root both sides. You can write it as 3k over 5 pi power 1/3. So this is our stationary R value. Now we need to check, whether or not this R value gives us a maximum or minimum surface area. So we need to do a second derivative, d2a dr squared. So I'm differentiating the first derivative another time. This will give me 10 over 3 pi plus 4k over r cubed. Okay. So let me shift this over a little bit. When r equals to 3k over 5 pi power 1/3, d2a over dr squared equals to 10 over 3 pi plus 4k over r cubed. So the cube and the power 1/3, they cancel each other. So we have this 3k over 5 pi power 1. Very nice. So 10 over 3 pi plus 20 over 3 pi. We have 10 pi, which is more than 0. Therefore, we know that S is minimum. The surface area is minimum when R is 3k over 5 pi power 1/3. Okay, so we have found the R value that will give us the stationary value, which is 3k over 5 pi power 1/3. And then we have proven that with this R value, the surface area is a minimum. But we are not done yet because we need to find the H value as well. All right, so besides finding the R, we are also supposed to find then the H. So H, according to our working in the earlier parts, is 3k minus 2 pi r cubed over 3 pi r squared. So let's substitute the R values in. 3k minus 2 pi r cubed. So 3k over 5 pi. The 1/3 and the cube cancel each other off over 3 pi r squared. So this is our theta. Simplifying, we have 3k minus 6 over 5k over 3 pi. So I am grouping these three terms together, all right? And then 1 over 3k over 5 pi power theta. Later you will see why I'm doing this, all right? So putting 3k minus 6 over 5k over 3 pi together, I will get 3k over 5 pi. So can you see this? 3k over 5 pi power 1 divided by 3k over 5 pi power 2/3. So they cancel off each other and we have 3k over 5 pi power 1/3. All right. So this is our H in terms of K. So you guys might want to pause the video now to take down the working and to see what's going on, because I'm gonna erase the working to move on to question 2. Okay, moving on to 10 part 2. It is given instead that the volume is 200 cm cube. In other words, our K value is 200, because earlier in the question, they told us that the volume is K. All right, so K is 200. And the surface area is 180. So surface area, we know that it is 5 pi r squared over 3 plus 2k over r, and they tell us this is equals to 180. So what we do is we multiply 3r to every term so that we make this a one-liner. 6k equals to 540r. But remember, this question, they told us that the k is 200, so this becomes 1002. So rearranging in descending powers of r, we have a cubic equation in terms of r. So what we will do is we will use the GC to solve this equation for us. Okay, so for your convenience, I have saved some screenshots for you to see. So we will go to application. We will choose number 4, polynomial. Go to polynomial root finder, degree 3, order 3. Okay, because this is a cubic equation. Then you go next. Key in the coefficients. So in this case, the coefficient of, if you are looking at your working, the coefficient of r cubed is 5 pi. So if you key that in, you will get this long decimal. There is no r squared term in our working, so r squared is 0. Then the rest, you key in accordingly. And when you solve, you get these 3 solutions. All right, so I'm gonna put them into my working. Using GC, I have 3r value. R equals to negative 6.7587, 3.7215, 3.0378. I will reject the first answer because radius is a physical quantity. It cannot be negative. So I'm left with, out of 3, I'm left with 2 possible answers. Now let's check which one of the 2 we will be keeping. So if r equals to 3.7215, my h value is actually 3 times 200 because k is 200 minus 2 pi r cubed over 3 pi r squared. So this h expression, you can see them in your earlier working in part 1. All right. So if you key this into the calculator, you will get 2.12, which we will reject because the question tells us that the radius is shorter than the height. But in this case, my height is actually shorter than my radius, okay, which is contrary to what the question is saying. So we will reject the first answer. For the third R value, 3.0372. So let's check this. Minus 2 pi r cubed over 3 pi r squared. Okay, this will give you 4.88, which we will keep because, like the question mentioned, the radius is supposed to be shorter than the h value. So r equals to 3.04 to 3 SF, h equals to 4.88 to 3 SF. Right? So this is how we do question 10. Just to highlight, you realize I did the rounding off. Oh, this is 3.04. I did the rounding off in the last step. All right. And when I was doing the intermediate steps and the calculations, I used the 5 SF answers. So make sure you practice this as well. Intermediate steps, 5 significant figures. Unless question says otherwise, we only give them the 3 significant figures answers in the final step. All right. So that's how we do question 10. I see you guys in the next video on question 11, which is on a couple of topics, parametric equation, as well as application of integration. So I see you guys in the next video.